Hello folks, have you ever wondered what if your imagination can be turned into reality? It would be fascinating, right? A 3D printer will make this happen for you. We will give you an overview of this magical machine called 3D printer. Let's first find out the learning outcome of this video. That is, in this video, you will learn about what is a 3D printer, methods of 3D printing, how does a 3D printer work, what are the steps of 3D printing, what is 3D modeling, different types of 3D modeling softwares, introduction to Tinkercad 3D designing software, designing of 3D model using Tinkercad software, introduction to slicing software Cura, how to convert 3D.stl model into Gcode, hardware parts of a 3D printer, process of 3D printing an object with a 3D printer, the uses of a 3D printer, and why should we use only a 3D printer? Let's begin by understanding what a 3D printer is. A 3D printer is a computer-aided manufacturing device that creates three-dimensional objects. The 3D printer receives digital data from a computer as input. However, instead of printing the output on paper, a 3D printer builds a three-dimensional model out of a custom material. 3D printers can be used by all, and it doesn't need any previous machine operating experience to get you started with this. Using this printer, we are certain that it will take your skills and design thinking to the next level. Methods of 3D printing. The first method is through fused deposition modeling, FDM. It is a common approach in which the part is printed by extruding molten strings of material that melt together to create the part. The second method is selective laser sintering. This method is more common in an industrial style prototype setting. A laser melts together powdered plastic, ceramic, or other material, then spreads more powder on top, repeating the process to build the part layer by layer. The third method is powder bed and binder. This process is similar to laser sintering. An inkjet head distributes binder to the correct location on a bed of powder. The fourth method is stereolithography. In this process, an ultraviolet laser hardens resin in a vat layer by layer until the part is built. It can quickly create high-definition parts that can be machined. How does a 3D printer work? 3D printer works by extruding the molten filament through a tiny nozzle that moves in X, Y, or Z axis. The printer creates a 3D model in a few hours by turning a three-dimensional CAD drawing into lots of two-dimensional layers or cross-sectional layers. What are the steps of 3D printing? First of all, you need to create a 3D model or a design using the Tinkercad 3D designing software and save that model in .stl format. Then this 3D model in this format is converted into Gcode using the slicer software. This software slices the 3D model layer by layer and converts it into the machine language called Gcode. This Gcode is then uploaded into a 3D printer to print a 3D model, and the printer then prints the model. What is 3D modeling? The 3D modeling is the process of developing a mathematical representation of any surface of an object. It is achieved by building a three-dimensional object using a computer-aided design, that is CAD software. Here is a list of a few 3D modeling softwares: Tinkercad, ColabCAD, Blender, SketchUp, 3D Builder, Sculptris, FreeCAD, Autodesk 123D, MakeHuman. Now let's have an introduction to Tinkercad 3D modeling software. Tinkercad is a 3D design software which consists of a few geometrical shapes that can help us create the designs that we wish to. You can explore many designs using these shapes, and once final, this becomes our 3D design model. You do not need any previous CAD design experience to get started. All you need is a creative mind with a spoon of passion determined to create something using this 3D design software. The best part is, it is free to access and available to anyone with an internet connection via a web browser. Tinkercad makes it easy for students to learn a staple of the design process, combining multiple simple objects to make more complex shapes. It also allows students to design their own shapes or pick shapes to subtract from their projects, providing an easy way to create arches or holes using negative space as a tool. For using this software, you need to create your account and log into the software on your browser. To design a 3D model, we need to select 3D design category and then click on Create New Design. When you click on Create New Design, then the default screen of 3D designing will open. As you can see, the default screen is divided into different sections and their functions. This blue plane at the center is called a work plane. You will be doing all your designing here. This area on the right consists of various geometric shapes, which you will use for creating 3D designs. You just need to drag and drop the shapes from here to the work plane. There are many more shapes other than these basic shapes, which you can select from here by dragging this option down. These menu items on top right are used for various operations like group, ungroup, align, and mirror. These options here on the top left corner are used for operations like copying, pasting, duplicating, delete, undo, and redo. This is the navigation option, looking like a Ludo dice. It has 6 sides, which are called as front view, back view, right view, left view, top view, bottom view. This navigation option gives us a free hand to design into any view we desire. You can also rotate your work plane using the right click of your mouse and moving it. Here are a few options on the left side of the screen which will help you in designing. This is the home view that brings back the design in the normal view as we get in the beginning. This Fit to View Shape option is used to directly view only selected shape to fit the screen. This option is for zooming in, and this one is for zooming out. This option is for changing the views to orthographic and perspective view. Orthographic is 2D view and perspective is a 3D view. This import option is for importing files in .stl, .svg or obj format from your system if you need to work on them to make some changes in their shape and design. This export option is used to save your design in any of the formats mentioned, .stl or .obj or .svg. You can also share your design to anyone using this Send To option. Sharing can be done through generating a link of your design through the invite option. Now let's see how we can design any model on Tinkercad. First, we will design a keychain. Let's get started. Take a box from the basic shapes and give the dimensions as length 80 mm, width 20 mm, and height 5 mm. Please note, all dimensions will be in millimeters, mm. Drag and drop the text feature on the work plane. In the dialog box, which appears on the screen, edit the text as the name you want written on the keychain. Give dimensions to the text: length 55 mm, width 7 mm, and height 3 mm. Now lift the text from the bottom plane using a cone till 5 mm and place it over the body of the keychain. Arrange the text manually or using the align feature as required. Using the left click, make a rectangular box to select the body of keychain and text used. After selecting the body and text, click on the group icon as shown above to group everything together to be one single part. Select a cylinder and give it the dimension: diameter 3 mm and height 5 mm. Make that cylinder a hole and group it with the body of the keychain. A hole with the dimension of the cylinder will be made on the body. Drag a ring to the work plane and give the dimensions as length 15 mm, width 15 mm, and height 5 mm. Place the ring in the hole made in the keychain body. Now group the two bodies together using the group option. And finally, your design is ready for 3D printing. Now you can save your design on your PC by clicking on Export and then clicking on .stl. Now we will design a spanner. For designing a spanner, we divide it into 3 units: the jaw, the handle, and the ring. To design the jaw, first drag and drop a cylinder and a polygon from the basic shapes to the work plane. Now give the height of the cylinder shape as 10 mm and the diameter as 30 mm. Mm refers to millimeter. Now put the polygon shape on the cylinder like this. Now click on the polygon shape and then click on the hole to make it hollow. Note, the height of the polygon should be more than the cylinder. Now select all the shapes. Then click on Group icon for grouping both shapes. Next, to design the handle of the spanner, we will follow the steps here. First, drag and drop a box shape from the basic shapes to the work plane. Now give the height, width and length of this box. Height of the box, let's keep it at 10 mm. The width of the box at 15 mm. The length of the box set at 100 mm. Now to design the ring of the spanner, first drag and drop a cylinder and polygon from the basic shapes to the work plane. Now give the height of the cylinder shape as 10 mm and the diameter as 30 mm. Now give the height of the polygon as 10 mm and the diameter at 20 mm. Note, the diameter of the cylinder should be more than the polygon. Now increase the number of sides of the polygon. Now put the polygon shape on the cylindrical shape like this. Then click on Align to centralize both shapes. Please note, when the middle dot will become grey in color, then the middle object is centralized. After centralizing both shapes, now click on the polygon shape, then click on Hole to make the shape hollow. Now select all shapes, then click on Group icon to group both shapes. Now the final step is to group all the units. First, place all parts in a line like this. After that, align them using the Align option. Then click on Group icon. After grouping all the items together, the spanner is ready. Let's give you an introduction to the slicing software Cura. First, start with understanding what is slicing. The slicer, also called the slicing software, is computer software used in the majority of 3D printing processes for the conversion of a 3D object model to specific instructions for the printer. It converts the 3D.stl file into Gcode, which can be read by a 3D printer. What is Cura? Cura 3D is a slicing software for 3D printers. It takes a 3D model and slices it into layers to create a file known as Gcode, which is the code that a 3D printer understands. Installing Cura. We will be using version 15.04.06 of Cura. First of all, download the version 15.04.06 from the given link. Now, open the installation file of the software downloaded and follow the steps for installation. After installing Cura, start up. It will open this window. You can add a new machine if required from the menu at the top of the screen. Select Machine, Add New Machine. Please note, when you open Cura for the first time after installing it, it will ask you to choose a language. Choose English. Then click on Next. Choose the option Other and click Next again. Choose the option Custom from the given options and click Next. Fill the data according to the specifications of your 3D printer and click Finish. This will create the settings in Cura according to your printer specifications. Let's have an explanation of the settings. Basic settings. Quality. Layer height in millimeters. Print resolution in the Z-axis affects the level of detail printing and print time. The recommended values are 0.10 to 0.25. Printing at a resolution of 0.1 mm takes twice as long as 0.2 mm. Shell thickness defines the wall thickness of the print. Significantly affects the strength of the print as well as filling visibility. Recommended values are multiples of the nozzle diameter of 0.4 mm. Entering a value of 0.8 will result in a contour consisting of 2 layers of filament. Retraction. Retraction is the retraction of the filament during idle motion. It prevents threads of the filament from stretching between the printed objects. Fill. Bottom/top thickness. This parameter defines the number of layers at the top and the bottom of the print. The recommended value is a multiple of the predetermined layer thickness. Keep value to 0.8 mm. Fill density. Significantly affects the strength and length of the printing. It is best to determine the settings by experimenting while controlling for the look of the layers. For decorative prints with no mechanical load, use 0 to 25%. For mechanical parts, use 50 to 100%. Speed. Print speed. This needs to be adjusted depending on the complexity of the model and the type of filament. Higher speeds undermine the accuracy of the printer and print quality. We recommended not exceeding 70 mm per second. Support. Support type. Touching build plate. Supports are formed only on the surface of the work table. Everywhere. Supports are formed on the surface of the work table as well as on the model. Supports are required to correctly print sides that deviate from the work table by an angle greater than 45 degrees as well as overhangs. Sometimes it is possible to avoid the use of support. However, this affects the quality of the created surfaces. The supports are marked in blue in the layer view. Platform adhesion type. Cura creates structures to prevent the buildup of prints on the print platform. When printing on a perforated table, it is necessary to use raft to get a 8 smooth lower surface of the print. Brim. This is a series of strokes made on the outside of the print. They prevent the print from moving on the table and are very easy to remove. Raft. This is a platform created for printing. It effectively increases the adhesion of the print and prevents shifting, detachment, and curling. Filament. The diameter of the filament used in the motion printer is 1.75 mm. The value results from the construction parameters and is constant. Flow. This function compensates for deficiencies in the filament. The amount of filament fed to the head is increased or decreased by a predetermined value. This is useful when printing with flexible filaments. An increase from a few to several dozen % improves the printing of select elastic materials. Keep the flow at 100%. Machine. Nozzle size, a value of 0.04, is constant for the motion printer. Advanced settings. Retraction. Speed. The speed with which the filament is drawn into the print head suggested value is 85 mm per second. Distance. The amount of filament that will be drawn during retraction. The suggested value is 4.5 mm. Quality. Initial layer thickness. The application of a thinner lower layer results in poorer print adhesion to the work table. Recommended values are 0.2, 0.3. Initial layer line width. The percentage of the thickness of the filament thread in one layer values of 110 to 130% can improve adhesion to the table. Cut off object. This causes the model bottom to line up with the work table platform. A print fragment located underneath the table surface will not be printed. Speed. This menu allows you to set the speed for specific print fragments. Proper speed control can significantly speed up the printing process without compromising its quality. Travel speed. The speed with which the head moves when there is no filament being fed. Example, when passing between two models being printed at the same time. Suggested value 80 to 130 mm per second. Bottom layer speed. The printing speed of the first layer significantly affects the adhesion of the model to the platform. Suggested value is between 15 to 25 mm per second. Infill speed should be greater than the outline speed. However, while filling small areas, this may cause short, quick movements and consequently cause the printer to vibrate strongly. Top or bottom speed. The speed at which all of the layers closing off the object at the top and the bottom are printed. The parameter has a large impact on production times as well as the quality of the finish. Outer shell speed. The speed of the outer shell has a very large impact on the appearance of the print. The recommended value is about 12 to 18 for precision printing and advanced materials, 20 to 35 for easy materials with average precision, and 35 to 50 for printing prototypes. Cool. Minimal layer time. This parameter specifies how long it takes to create each layer. In the case of very slim objects, a longer time setting allows the material to solidify. The head waits for a specified time beside the object. How to convert a 3D.stl model into Gcode. For converting a 3D model into Gcode, you first need to load the model on Cura software. So for that, we click on this load icon. Now select the .stl file from your PC that you want to convert into Gcode. Then click OK, and this will load the .stl file on Cura. Now, before saving the file in the Gcode, we will see a few more options available and their functions. Rotation. Please note that the menu is only visible when a model is selected on the work table. When you click around the model, 3 circles will appear. Grabbing one of them allows you to rotate an object around its corresponding axis. The standard rotation jump is set at 15 degrees. Holding down the Shift key lets you rotate by 1 degree. Scaling. The drop-down menu displays the scale factors and the model dimensions for each axis. You can increase or decrease the size of the object by using the scale factor or typing the desired dimension. The lock located at the bottom of the window is used to maintain the aspect ratio of the XYZ axis during resizing. Opening it allows the deformation of the model. Reflections. The menu allows you to create a mirror image object relative to the X, Y, or Z axis. Alternative views. In addition to the standard view, the buttons in the upper right corner of the screen allow you to view the model in several other modes that let you better match the print setting. Standard view. The basic active mode for loading a model. Overhang. In this view, all of the edges that will potentially require the use of supports are marked in red. The program selects these edges based on the parameter overhang angle for support under the expert settings. Transparency. This view allows you to check the internal structure of the model. For example, to see if any overhangs require support. X-ray. This view shows the internal structures of the model. Overlapping edges and intersecting surfaces are highlighted in red. Layer view. One of the main views available in Cura. With the slider situated on the right-hand side of the screen, you can browse the model layer by layer by observing how the program builds the structure. Now, after performing the necessary actions on the model, you need to save it into Gcode. You can directly save it in a SD card by inserting an SD card in your PC, or you can save it in your PC. To save, click on this save icon here so that the Gcode will be directly saved in your SD card if you're using it, or you can save it in your PC at any location. Let me now introduce you to the hardware parts of a 3D printer. There is a printer body, heat sink, a heater sensor, a stepper motor, cooling fan, LCD display with smart controller, filament extruder, connection wires, heating bed, and a filament. Are you now ready to take a look at the inbuilt parts of a 3D printer? Well, here it is. This is the power supply switch. This is the rotary button. This rotary button works by clicking on it, and it moves clockwise and anti-clockwise, both sides. This is the LCD screen. Let me talk more about the LCD screen. When you see this LCD screen, it shows you some options. Let's have a look at these options. One is the nozzle. The temperature which shows here is 200 degrees Celsius. Heating bed temperature 50 degrees Celsius. The length represented as X, breadth as Y, and the height as Z of the printing objects. FR means the flow rate of printing objects, which is 100%. The SD card percentage, print time of the object, and the last option that you see is the SD card, whether it is inserted or not. There is also a toolkit box which contains glue, power cord, filament holder, clips, fuse, spatula or a scraper, tweezer, cutter, Allen key, a spanner, an SD card, and a nozzle. Let's have a look at the process of printing a 3D object. You create any CAD model and save it in the .stl format. Using the slicer software, convert the .stl file into the machine language called Gcode. The final step is to print your model and wait for a few hours to get your final model printed. And it's done! Let's have a look at how to operate the 3D printer machine. Let's begin with the first step. How do you give the power connection to a 3D printer? Open the 3D printer toolbox. Take out the power cord and filament holder. Give power supply to the 3D printer using this power cord and switch on the 3D printer. Let's find out how to place bed before preheating of 3D printer. Put the Fevicol on the glass bed. Spread the glue all over the glass through a spatula. Take out the clips from the toolbox. Place the glass over the heated bed of the 3D printer. And finally, clip the bed of the 3D printer. Whenever you are using the 3D printer, please note that you need to make sure that the 3D printer should have been preheated at 200 degrees Celsius. And how do you preheat the printer? Simple. Press the rotary button to switch on. Click on the Prepare option. Go to the Preheat PLA. PLA stands for polylactic acid. Click on Preheat PLA. Wait till the nozzle temperature reaches 200 degrees Celsius for PLA. And it's done. How do you insert PLA in 3D printer? Connect the filament holder to 3D printer. Hang the PLA on filament holder. Now press the extruder into downwards direction and pass the PLA from the two holes while pressing the extruder. Now the PLA will pass through the pipe and insert the filament into the nozzle inlet. Push the tube inside the hot end till the end point and press gently till the material starts to come out from the nozzle as shown. So now your 3D printer is ready to print any object. Okay, how to insert an SD card in the 3D printer? Insert the SD card in the given SD card slot. When you insert this card there, it shows on the LCD screen whether the card has been inserted or not. How do you give it the command to print? SD card is already inserted in your 3D printer. Go to the Print from SD card and give the print command. Here I am showing you that I am giving the print command to a twisted heart vase model for the printing. And now your 3D printer is ready to print this vase model. Here you can see your 3D printer is printing the first layer of the model. Interesting, right? You can do this too. How to remove parts from the 3D printer. First, remove the bed clips. Then, take out the removable glass. After that, take the spatula from the toolbox. Just with a gentle push of the spatula, try removing the print from under the glass bed. and it should be done. Talking about the uses of the 3D printer, there are many industries which use the printing machines. And which all are there that use the 3D printer? There is the food industry, the bioprinting industry, the medical industry, they print medical devices, the industrial art and jewelry, the automotive industry, computers and robots and other ICT things, and education and research also use 3D printers. Apart from that, the 3D printers help you print 3D selfies and rapid prototyping and manufacturing. Why do we use a 3D printer? For designing a prototype of any model, for printing solid objects, toys or useful things. You could even use to print the parts of a body. And even students in universities and colleges can use these. Like chemistry students can print out 3D model of molecules, and medical students can help print out human body parts using this printer. And why should we choose a 3D printer? Because of the following reasons. It has a flexible design. There is an ease in developing complex objects. It has light-weighted parts. It gives us a fast design and production. It minimizes waste. It is definitely cost-effective. And it is very easy to use for anyone, even if you do not have an experience of working with it. Some frequently asked questions related to this topic are being shared with you along with the answers. Question 1. Is there a difference between 3D printing and additive manufacturing? No. The term 3D printing comes from the use of inkjet printer heads in the first 3D printers to deposit either layers of UV curable photopolymer resin or a binding material onto a layer of powder in a powder bed process. However, the term now universally encompasses all additive manufacturing technologies. Question 2. Who invented 3D printing? Charles Hull, the co-founder of 3D Systems, invented the solid imaging process known today as stereolithography, SLA. This was the first commercial 3D printing method. He first thought of the idea in 1983 while using UV light to harden tabletop coatings. In 1986, he received the patent for the process. Question 3. Which file formats does Cura support? Cura supports the following 3D file formats: 3MF, OBJ, and STL. Supported 2D images are BMP, GIF, JPG, and PNG. Let's come to the assignment. Design a London Tower bridge on a Tinkercad software.